So get off your act, let's do some math. Math, 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 math.
Hey everyone, and with that, let's do some math. So here we are with 10.5's lesson for geometry angle relationships in circles. We're going to be finding angle and arc measures, and we're also going to use circumscribed angles. So the main part of it is just going to be finding angle and arc measures. First, let's do a little cartoon of the day. So notice all the computations, theoretical scribblings, and lab equipment, Norm. Yes, curiosity killed these cats. Alright, a little Far Side cartoon. So on page 300 of your notes, we're going to see quite a few of these here, theorems and core concepts, but we'll start with this one. It's a tangent and intersected chord theorem. So if you look at the diagram over here, you have your circle, you have a tangent line. Remember, tangent is a line that's just kind of grazed the edge of the circle here at a point of tangency, which would be A. What that creates there is it actually, with a chord, if you have a chord going from there to another point where it's at B, that creates two angles here. So there's our 1 and our 2 for the angles. So it's as if a tangent and a chord intersect. So you have this chord and the tangent, the point of tangency is right there where the chord is touching the circle. So since the measure of each angle formed is 1/2 the measure of its intercepted arc. So the measure of these is going to be half of what the measure of this arc here is. So on the red one here, the measure of 1 is going to be half of what the arc AB is. And for the measure of 2, that's going to be half of what this blue arc is, the arc for ACB. So you just need to know that it's going to be half. Okay, so we kind of saw a half before when we had an inscribed angle. When we had that angle in there, that was half of its intercepted arc. So it's very similar to that theorem. So it's using the same idea where you're going to just multiply by either 2 to get the arc, or going to divide it in half to get the angle measure. Okay, our extra practice here, we have the line CD is tangent to the circle. That's what it tells us. Find the indicated measure. So here's our tangent line. Here's a chord as well. So point B is our point where the chord and the line that's tangent here intersect. Creates two angles. One over here, it says it's 70 degrees. And this other one over here, ABC, is the first one we're trying to find, number 1. So what is the angle measure for ABC? Well, if this is 70, this is a straight line right here. This would be considered like a linear pair. I remember that back from chapter 1. That's a linear pair where those two add up to 180. Straight lines are 180. So 180 minus 70 would give us our number there. That's 110 degrees. You can definitely see it's a little bit more than a 90-degree angle. So 110 degrees for that angle on this side right here. Those two add up to 180. Then it says find the measure of arc AB. So AB is this arc on this side over here. So we're looking for this arc. So if this is 70, then that arc is going to be 2 times 70, which is just going to be 140 degrees. So the measure of this arc is 140 degrees. And then number 3, measure of AEB, arc AEB. So that's this longer one over here on this side. So if this is 110, then this arc is going to be twice of that, because this is half of what the arc is. So the arc is twice of what the angle is. So again, 2 times 110, that would just give us 220 degrees for the measure of the arc. And this should add up to 360, right? Because we have 220 plus 140 would make the whole circle, that is 360. Hey, number 4 and 5, we're told two things. We're told that the measure of arc ADB is 220 degrees. So from A, we measure arc ADB. So that's going to be out here. So this side is 220 degrees. Not sure why they used ADB. Maybe D is right here. There we go. Okay, yeah, this point is C. Almost got confused there. That's not D. D is here. Yeah, there it is. So that's D right there. So A to D to B. That's what they're saying there is 220 degrees. That's this whole arc here. The measure of angle B, that's right into here, is 21 degrees. So put a little 21 in that one. Now we want to find the indicated measure. We want to find the measure of arc AB. So that's going to be this arc on this side So that's the rest of the circle. So you have this arc that we know is 220. Here's the rest of the circle. So circles are 360 degrees. We just need to subtract 220 from that, and that would give us 140 degrees. So that's the measure of arc AB is 140 degrees. So if we know that's 140, we're now looking for the next thing right here, the measure of angle ACB. So we got measure of angle ACB. A to C to B, that's what I'm trying to find out, this measure. And like I said, we know that our arc over here is 140. Now this arc here is 140. So that means that this angle that's right in here, right where this angle is, where A is to B this way, this angle right there is half of 140. That's got to be 70 degrees. Okay, just from our theorem that we just saw. Okay, that this is going to be this is twice of what the angle is, or this is half of what the arc is. And so if this is 70 and this is our point of tangency right here, so that's our tangent line, then that makes this a straight line. So on this side of this line, of this chord really, it's going to be 180 minus 70, that's going to be 110. We kind of saw that same thing before. So now I have 110, 21, and the mystery one over here. So we can just say, well, I know in a triangle, this is what we have now. In a triangle, all angles add up to 180 degrees. So we can say 180 minus 110 minus 21. When I subtract all of that, I get 49. So 49 degrees is our angle measure over here. Okay, so back to page 300 on that whole list of stuff on that side. Here's a core concept, and it just says intersecting lines and circles. If two non-parallel lines intersect a circle, there are three places where the lines can intersect. So one of them on the circle, we've already seen this one. So this would be the inscribed angle right here. We've seen that. We know that this angle right here is half of what its intercepted arc is here. That was in the last lesson. But now we are finding out there's two other ones we could have. We could have the two lines intersecting inside the circle, and that's not a center point. So it's not a central angle. These are not central angles. And so we're going to see there's a theorem concerning these angles as well. And then it also could be outside the circle. So a point on the outside of the circle. Basically what we have now is we have an angle on the outside. We have this arc here, but we also have another arc right in here. You can barely see it. There's a very small one. We'll see it a little bit better on the next part. So right there at the bottom of, so here's our ones for inside the circle and the ones for outside the circle. So that's what we got here. So angles inside the circle theorem. The one for on, like I said, was in the last lesson. That would be the inscribed angle. This one, now we have angles inside the circle theorem, where this is not a center point. So what we're going to see here is that these angles inside of here, like 1, now these are going to be the same, of course, because of vertical angles. So 1 could also be over here. So we would see that basically 1 here, this angle 1, is half of these two arcs added together. So the two arcs, you add the two arcs together, and then you can divide it by 2, and that would give you the measure of the angles that are inside here. Same thing for number 2. You would add up the arc from AD and BC over here, add those up, and then divide by 2 to get the measure of the angle for 2 and the other side over here. For the one here, this is now the top of 301. So 301's top here. Angles outside the circle theorem, we have basically 3 options. You do have 3 possibilities here when you have an angle on the outside of the circle, because what you could have is you could have one of the like legs of this angle as kind of tangent, where it's just touching, and the other one could go straight through. So now you have an A and a B. You could also have a situation where you have both of them just touching in one place, kind of like 2 tangent lines right there. So you just have 2 points right there, and then this one is going through, kind of like the secants, like we saw, remember secants before, from 10.1, going through and through here, and now it makes these 2 arcs. So no matter what we do, we're going to make 2 arcs. So here on this first one, you're making an arc here with the B to C, also an arc here with A to C. And so you're pretty much doing the same idea as up here, except this time when they're outside the circle, you notice the difference is you are subtracting and not adding. So here, when the intersection is inside the circle, you're going to be adding the arcs together, then dividing by 2. Here, when it's outside the circle, you're going to be subtracting the larger arc minus the smaller arc. And this one's obviously larger out here. Your one on the outside here will always be larger than the one on the inside. So it's highlighted in red. So the red one's going to be bigger on the outside here, always minus the blue one on the inside, which is always smaller. So the outside one minus the inside one for those arcs divided by 2. So you're subtracting them. The bigger one minus the smaller one and then divided by 2. So it doesn't matter what situation you have, you're going to do the same thing on all of the situations. Okay, on 6 through 9, we're finding the value of x. So we're going to be using what we were just looking at. So we could see on 6 and 7, the intersection is on the inside. So here we're going to be adding. And on 8 and 9, the intersection is on the outside. So we'll be doing some subtracting on those ones. So this one will be probably the easiest one. Number 6, you just have some numbers here. So we're trying to find the value of this inside angle right here. So what we have to do there is for find the value of x, so x is equal to, so this equals basically the arcs added together on each side of this. Remember, this makes vertical angles, so x is the same on that side. So these arcs here added together, 50 plus 92, and then we have to divide it by 2. It's the same thing as multiplying by a half is also dividing by 2. I usually just like to say divided by 2. So now 92 plus 50, that's going to give me a 142, and when 142 divided by 2, that's going to give me 71. So that's our value of x on that one, just 71. Now number 7, we're going to have to get a little creative with this one because we're given the arcs for these angles and we're told the kind of the expression of the angle measure for this side over here, and we're not told the arcs over here. So this one's going to be a little more creative. What we're going to need to realize is that this angle right here is supplementary to the other side of it over here. So these two here add up to 180. So if I needed to figure out what this angle is, that's really what I would be nice to have. It'd be better to have this angle, just like I did with the x and those numbers. I have the 97 and the 35. It'd be good to have this angle. So how do I get some kind of expression to represent this angle? Well, if this angle right here would be 180 degrees minus this angle, that's what we're going to say. 180 minus this binomial. So that's what we're going to put for this angle right here. It's 180 minus this binomial. Now you need to put it in the parentheses. Keep it in parentheses there. 5x plus 14. So now what we can do is we can say that this angle here is going to equal these two adding together divided by 2. Same thing like right here. So my x is now this whole thing. So I'm going to say, okay, this whole thing here, which is where the x is, just like I had just a single x over here, now I have a whole big expression with x, and it's equal to the arcs added together and then divided by 2. So 97 plus 35 divided by 2. So what I need to do here is I need to distribute the negative inside of this. I need to add these numbers on top here. So as I do that, it's going to give me negative 5x minus 14. As I add those numbers up on top, it's going to give me 132, now divided by 2. I want to combine like terms here, so 180 minus 14, and I'm also going to divide the 132 by 2 at this time. So I have a negative 5x plus a 166. That's the 180 minus 14, 166. 132 divided by 2 is 66. So now what I'm going to do is I'm going to subtract 66 from both sides. We're kind of home free now. We know what to do. Just subtract 166. So that's going to give me negative 5x over here. Take 66 away. That's a negative 100. And then just divide by negative 5. 100 divided by negative 5, x equals 20. So there's our value of x. Okay, coming down, number 8. This one should be fairly straightforward and easy because it just has an x here. This time, though, we want to subtract. So to figure out, okay, so we're going to say the measure of this angle, which is at 38, are these two. So this is the bigger one, x is the bigger one, minus the smaller one, 72, divided by 2. So it's going to start off with 38 equals. The measure of the angle here is going to equal x minus 72. So the x minus 72. and that's all divided by 2. So this one is not plus on this one. When it's on the outside, it's a minus. And now what I want to do is multiply both sides by 2 to get rid of my fraction since x is over here. So we'll do that. We're going to get 38 times 2 is 76. And now all I got to do is just add 72. So when I add 72 to both sides, I'll end up with 148. So my answer for x there is 148. And then number 9, here we have some bigger expressions. So it's going to make a bigger equation for us, but it's the same idea. 28 is the angle measure, so 28 will equal this one on the outside minus this one on the inside divided by 2. So let's start writing that out. So starting out with the angle measure, 28 equals the bigger one, 4x plus 8, is going to be minus, so we're going to start with the 4x plus 8 minus this one here. Now I need to definitely keep this one in parentheses. Notice I didn't put the 4x plus 8 in parentheses because I didn't need the parentheses anymore. But I still need these parentheses here because I have to distribute the negative into this. And that's all going to be divided by 2. Remember, we still have to multiply by a half, or I like dividing by 2. And so now at this point, we would want to multiply both sides by 2, just like we did over here, multiply by 2. So 28 times 2, that's going to give us 56. And so I can also at the same time distribute this negative into here, so it's 4x plus 8 minus 3x minus 2. So now what we have is there, we want to combine like terms. I have a 4x and a 3x, or negative 3x, it's going to be 1x. 8 minus 2 is 6. So 56 is equal to x plus 6. Then we just subtract 6 from both sides. 56 minus 6 is 50. So our x on this one equals 50. So there's our value. So here, let's take a little short break for the joke of the day. Why did the apple run away? Oh, poor apple. Why did the apple run away? Well, because the banana split. Wouldn't mind a banana split right now. Okay, we're getting close to our end here, so a circumscribed angle. I know we don't have any more in the extra practice, but we're still going to do a couple more problems. The circumscribed angle here is this. Basically, when we saw that situation right there, the angle is around the outside of this circle. So that would be considered a circumscribed angle. So a circumscribed angle is an angle whose sides are tangent to the circle. So that's that one. Remember, it does have, this is on the outside of the circle, so we still have the same things. This angle is these, this one minus this one divided by 2 to equal that angle. But we're going to see something else going on with these ones and a center point. So if we have a center point right here, that's going to make something special. That's what our next thing is going to show us here. A circumscribed angle theorem. So if we have now this circumscribed angle and a center point, and then basically a radius going to each point of tangency. So from A to C and B to C, it creates, and kind of what it does create here is a central angle. And we know for this central angle, that's the same as its intercepted arc. So this arc AB right here is the same as this central angle that's inside here. Okay, so let's look at this one. It says circumscribed angle theorem. The measure of a circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc. So basically the measure of our ADB, so that's this angle outside here, this measure out here. Now we already know how to find that measure if we know this arc and that arc. But if we don't, if we know something else, like we know the central angle here, we can say that this angle right here is 180 degrees minus that ACB angle, that central angle. Or it's also the same thing as this arc here. That's another way we can do this. Okay, just 2 more problems I'm going to have you do from this theorem that we were just looking at with the circumscribed angle theorem. So at the bottom of page 301, so go back to page 301, right underneath where that theorem was, that circumscribed angle theorem, right at the very bottom of the page, we're going to do 6 and 7 here, so these 2 right here. So if we look at number 6, you can go ahead and draw this. You can just do a quick little sketch of the circle and this angle, that's X out here, put a center point and label these all K, M, and L, and then 20 goes there. So draw this first. If you need to pause the video, you can pause the video while you're drawing it. And so now we want to look at, see, okay, how do we find the value of x? It's just what it says, or find the value of x. What's x? So we don't know what this arc is out here right now. We could find it, I suppose, because we know that this arc here is 120 degrees, but a quicker way to do it, we could just say, now since we know this central angle is 120, this is 180 degrees minus this 120. So for number 6, it's just 180 degrees minus the measure of angle KML. KML is our central angle there. So it's going to be just 180 minus 120, which is 60 degrees. So x is 60 in this one. For number 7, go ahead and do the same thing by drawing this one. Draw the circle, the circumscribed angle here. Draw the angle inside here. And this is a little bit different because you notice this one doesn't have the central angle. It actually has an inscribed angle instead. So a little different with this inscribed angle. So we have to think about this a little bit here. What we do know is that as far as an inscribed angle, its intercepted arc, this arc PQ, is 2 times of what this inscribed angle is. So I would multiply this x by 2, and now this is 2x. And this angle, or this arc I should say, PQ, is exactly the same as this central angle right here. So if I was to, again, draw a radius from R to Q and from R to P, that would be the same thing as this arc. Remember, the central angle is the same as its intercepted arc. Well, if this intercepted arc is 2x, then this central angle is also 2x. So there you go. We can find out what that central angle is. And so now this 50 degrees is 180 minus the central angle. Just like we saw this. The angle out here was 180 degrees minus the central angle. So that's what we're going to set that up now. So we're going to say 50 is equal to 180 minus the 2x, because this is now 2x. I can't write on this up here, so you may want to go ahead and do a little central angle of your own and write that is 2x there. That's where we're getting this 2x from. And now I'm just going to go and solve this. So I'm going to subtract 180 from both sides. That gives me 130 is equal to negative 2x. And then just divide by negative 2. So x is equal to positive 65. And so that's what we have. So number 6 we can see the answer was 60. And number 7 it was 65. All right, so that concludes our lesson for 10.5. You'll be able to go on to the assignment now, and I'll see you in class.